acceleration. So before you know about the displacement, you know about the distance, how both of them different. You know about the velocity and the speed, and also instantaneous velocity. But acceleration is a vector as well. The rate of change of the velocity equal divided by time, which is this one is the average velocity. It's like, you know, the V average is the displacement over time. So the difference between V2 to V1 here, I will release it, and divide by T, also the average of acceleration. And how about the instantaneous acceleration? Is also the acceleration at one specific time point. So what you do about the instantaneous, you divide by T. So use the differentiation with T, V dV by dt, so that you're gonna get the instantaneous acceleration. So it means like if you have the relation between Vt graph, the diff of V is the slope on initial part of the Vt relation. Acceleration happens when the object change speed from initial speed to the final speed. With the kinematics, you use AV to explain the motion of the object that it happened. But in dynamics, you will know the reason behind this change is the force. And you can calculate the force that introduced the change of the velocity, which is related to the acceleration and mass as well. So this you can see the acceleration not only increase for accelerate this truck to surpass that airplane, but also decelerate as well. You can see the parachute come out of this truck for deceleration. So the acceleration can be increased or decreased due to the acceleration or deceleration. Sorry, here. What I'll state here. This is deceleration. And this is acceleration. It can be happen whether it's increased in this part is acceleration or decreased here as a deceleration. I will go down. This is the represent of deceleration. And this is part of the acceleration. Right. So you can use this information to explain the motion of the object that you interest. The same runner here keep running. Now you would like to determine the average acceleration and instantaneous acceleration of this guy. Right. So from what you know, the instantaneous velocity is the differentiation of xt to dt, right? When you diff this, what you got minus 4 plus 4t for your vt here. If you like to find the average acceleration, a average is v2 minus v1, right, by t. So you have to find v1 and v2 as well. Now we're gonna find v2 and v1, which is v2 is the time at 3 seconds, right, and v1 as 1 second. So now I'm gonna sub the value in already, so that this is minus 4 plus 4 3, and this is the minus 4 plus 4 1. So v1 is 0, right? And how about v2 or v3 here, because it's at 3 seconds. I'll write v3 here. So this one is okay. Oh, sorry. is 8 meter per second. It also means meter per second. So that you can find the A average equal to 8 minus 0 divided by 3 minus 1 is 8 over 2 is 4 meter per second square. If you would like to define as a vector, put the direction to it because it's moving back forward in I hatch direction. So this is your average acceleration. But if you would like to determine the instantaneous acceleration, as you know from the definition, you can differentiate by t with the vt. So that in the vt, so that I will write down the vt that we have above here, minus 4 plus 4t, and you differentiate it. So this is a constant. When you differentiate, it goes to zeros, right? But 4t, now you got 4. So now you get the instantaneous A equal to 4 meter square. So if it's vector, put the direction to it. How about at t equal to 2.5 seconds? Because there's no t here, so A at t equal to 2.5 also equal to 4. So this means in this motion of this guy, the runner here, they're moving with constant acceleration. So the time change or time, any time point, the acceleration equal to plus 4 in forward direction. This is how the displacement, distance, speed, velocity, acceleration, whether it's in instantaneous point or averaged, you can already know it. Now you can use this information to approximate or predict the motion of the object or thing that you interest. Now this is another interesting problem as well. You already used all these kind of information before, but now we're gonna do quick drill on this problem. So think about the particle moving. Now it's moving in x direction only. So I'll represent the expression of Vx here equal to 40 minus 5t square in meter per second. So this is moving only in x plane in this term, or maybe backward. It depends on the function. So if you would like to find the acceleration, average acceleration, so now you have to find v2 minus v1 over 2, right? Which is over t, sorry, over delta t. So which is your v2 is v at t equal to 2. Now you sub everything in, it's 40 minus 5 and 2 square. How about your v1? v1 is v at t equal to 0. So it's 40 minus 5 and 0 square. So you got 40 meter per second for v1, and you got 20 meter per second for v2. Now you can see the decrease of the speed. So A is supposed to be the deceleration, right? So AVG is equal to 20 minus 40 and divided by 2, because 2 minus zeros. So it's minus 20 over 2 is minus 10 meter per second square. If you define this as a vector, make sure you point down the direction of this quantity as well. How about the instantaneous acceleration? Here, if you state about acceleration at some point, so it's instantaneous, you just differentiate it d by dt of v x that has informed you. So that d by dt of 4t minus 5t squared. So now this is constant, it's gone. So you got this one. So it's gonna be minus 10, right? Because it's come from 2 and 5t here, right? So it's minus 10. So how about a at t equal to 2? So it's 10 and 2 on it. So this is minus 20 meter per second square. If you would like to determine it as a vector, put it in I direction. So in this case, what you can see here, this particle moving as this function, the velocity is no longer constant. So this is what happened. The motion with varying acceleration. So acceleration can change with the time for this case. And not only for this case, but normally in our real life, when you increase the speed or velocity of the car by pushing the thrust, so that you change the acceleration of the car all the time when you accelerate it or you brake it, right? So that the acceleration can change with the time, not always constant in our daily life. That is how this is happen. Okay, we will see more and more complicated case in terms of motion of the objects. As you see now, like in the first three figures, this relate the acceleration that is constant. So what you can see, in any period, the acceleration if divided by time is equal to 0. Does it mean there's no change of the acceleration, which is constant? But from the second one, this is not constant. It changes with the time. So when you see in individual period, the acceleration keep changing, and keep changing. I mean, if you differentiate the acceleration with the time, it's not equal to 0. But when it equal to 0, what is happen? So you can see if equal to 0 is turned flat, right? So in this case, is equal to 0, it's going to be maximum or minimum of the acceleration. So it can be maximum or minimum of the acceleration into that motion. Whether you know it's minimum or acceleration, you can see whether it's increase and decrease or decrease and increase. So this is how you investigate what is happening of the motion, whether it's in the varying acceleration or non-varying, which is constant acceleration. Okay, now we move to the example of this case. As you can see, the Vt here show with the graph to represent the motion of this guy, which is the area of Vt here is represent the displacement, because S equal to Vt, right? If you know the area underneath of the graph, you can see the displacement. How about the acceleration? Acceleration is V over t. This means if you find the slope of this relation, not stop, the slope of equation is your acceleration. The area is the displacement. So if you'd like to find the total distance of a whole running, the distance is all the path that you correct. It's not equal to the displacement, right? What you're looking after, the distance. This is the displacement. So now, if you like to count on the distance is equal to the total area. So you have to sum up this area, the first one, and the second one. And you can see a trapezoid image like this, the subtoroidal area, which is equal to 1 over 2 plus the parallel size. If you have this A and B and this C as a height, I will remove this out. The area of this trapezoid image is 1 over 2 A plus B and multiply with C. You multiply by C and then you got the area of this trapezoidal. So from this case, what about the height is 10, right? And what is the parallel? This is 4, this is 6 in terms of time here, right? So this distance on the first period and the second period, now you can sum it up. From the first period is 1 over 2 and 6 plus 4 multiplied by 10. And how about the second trapezoid image? The height is this is 10 is 2 each, so this is 18, right? This is 1 each, so you got 4 over here, 5, 9, right? 10, 11, 12. You got 12 lower here, 12. And how about this one? 1, 2, 3, 4. You got 4 over here. So the another one you get 1 over 2, 4 plus 12 with height 18. So now you can sum them up for the total distance. So this is what you get out of it is 100 over 2, right? And this is 1 over 2, 16 and 18. Do the final calculation. You get this one plus is 144 meter. This is the total distance, not a displacement, right? If you would like to find the average speed or average velocity, how can you find it? For average speed, you need a total distance. For the average velocity, you need the displacement, right? Already have the total distance, but how about the displacement? The displacement, you only count this as a plus sign because it's above plus v direction. This is minus v direction, so that this is a minus sign. So rather than you sum it up, you have the above one, which is number 2, minus with the below one, which is number 1. So now you get 94 minus 50. So your result is 44 meter. This is your displacement. So now of the total, not from 0 to 18, this is total, total. Right, from 0 to 18. So now what you can find, the velocity average and the speed average. The speed have no vector sign because it's not vector, it's scalar. And this is the speed, right? And this is the velocity. From the velocity, you need the displacement over time. For this, you need the total distance, right? Over time. So now you got 44 over 18, and this one is 144 over 18 in terms of meter per second. Please use the calculator to calculate it, but you will find this for your final result. Is this all the information that you learn? But now, if you like to find the displacement for the whole running, now you already know it, right? The displacement we already observed here, so will write down the displacement over here. This is the displacement that it's asking. So it's the above one, right, minus with the below one, which is I will see out 44 meter. But if you like to investigate the deceleration that reduce the velocity from here is 18 meter per second to 0, which is here. So you would like to investigate only on this part to this part. So what is the deceleration of the reduced velocity? This is the delta V over T, which is the deceleration, is it, right? So because it's V2 minus V1 over delta T. This is the slope of the graph from this point here to this point here. So this is 13 second to 18 second. So the difference here is 5 seconds. And delta V is 0 to 18. This is 18. So now you can find the slope from 18 over 5. So this is your acceleration now. So the acceleration or deceleration in this case is minus 18 over 5 meter per second square. Here is your answer, which is this one is minus 3.6 meter per second square. If it's running along the x direction, you can put the vector sign and as is as I. Okay, this is all the motion, and you learn about all the parameters and definition for explain behavior of the particle